You are most welcome this session. This is an easier session. It is a manageable session. And basically, we shall be talking about the expression of the strength of the active drug in pharmaceutical product or the amount in pharmaceutical product. This will be the objectives of this session. Shall just define the term strength. Shall explain different ways on how we express the strength of pharmaceutical products, and shall have a few calculations or a few examples uh, how to calculate the amount of drug present in pharmaceutical product. Now, as we discussed earlier, that all pharmaceutical products contain certain amount of active pharmaceutical ingredient or the API plus the inactive ingredients or the excipients. And uh, the strength is just used to express the amount of the active drug present in a dosage form. For example, if they tell you that paracetamol 500 milligrams, it means that the amount of paracetamol present in that tablet is 500 milligrams. I have here amoxicillin capsule, amoxicillin capsule 500 milligrams. It means that uh, the amount of amoxicillin active drug present in each capsule is 250 milligrams. However, not all products contain an active drug. Like for example, if you have water for injection, which is a pharmaceutical product, it does not contain any active drug. These are the different ways on how we can express the strength of a pharmaceutical product. International units, parts quantity, just using the metric system, as we've seen earlier. Percentage concentration, so we can just change to percentage concentration. Percentage concentration can be another way how you can express the strength of the active drug. You can also have parts per million, milliequivalents, milliosmoles. I shall be going further. Strength is key strength. I'll just see ways on how you can express the strength of pharmaceutical products. Let us first look at international units. This is a unique strength, a unique way on how you can express strength. International units, this represents the substance or the amount of substance, that produces a specific biological activity. This one just represents the amount of substance that produces a specific biologic activity. This is common in drugs like penicillins, nystatin, vitamins, insulin. I've given an example here, for example, for this statin oral suspension, BP. You know what BP means, pharmacopoeia. We're having 100,000 international units per mil. So this is the strength of the product. But this one just indicates the relative amount proportions, often used to indicate relative amount, indicate the relative amount of each ingredient was in a product. Parts themselves are unitless because you decide the units, you decide what the units will be, as shall be seeing in our next calculations. This is a simple calculation. They're saying if 3 tablets contain 975 milligrams of aspirin, how many milligrams would be contained in 12 tablets? You can see this is just a proportion. And how you can calculate this, you have to interpret this statement here. The 3 tablets contain 975 milligrams of aspirin, but they want you to say what will be in 12 tablets. So these ones will contain this. This is the expression. We avoid using the terms like what we used in high school of x or any unknown. We just give us this expression here to be good. And then this will be if you put this kind of calculator, you get this one in milligrams. However, the question wants you to calculate how many grams. So you have to convert the answer in grams. You can see that 1 gram contain 1000 milligrams. What about the 3900 milligrams? Here you have to use the inverse proportion, and then you calculate this one. Me, I just gave us the answer, but for you as a student, you have to show us how this one is coming about. Concentration, this defines the amount of active drug of the active physical ingredient in a medicinal product. Oh, this is the same thing as saying strength. So you can have the liquid and topical preparation strength all called concentration and involve two numbers written in a fraction form, and the numerator defines the amount of the drug present in the denominator or the quantity of the dosage form, the drug plus the solvent or the active or the other inactives. To put simply, the concentration tells us how much drug there is in a given dosage form. So this statement is like we are going back to the beginning where we are explaining the strength. However, this one is bringing us, why I brought it here, because it is bringing us to the percentage concentration, as we are going to see in the next slide. Yes, we're going to see the next slide. Um, Percentage concentration, medication concentrations are often written as numbers followed by the percentage sign. As you can see this sign, which means that this sign always means in 100. We know what this sign means. So if you're having 50%, it means that 50 parts in each of 100 units, 100 parts of the drug product. Now, the percentage concentration of an active drug and inactive concentration in the various types of pharmaceutical preparation can be defined by the following. Uh, these are the examples, as you can see. So we're having percentage weight in volume, or just written by that statement, percent weight in volume. The other one is percentage weight in weight. So it is written by that abbreviation. The other one is percentage weight, percentage volume in volume. These are the ones we are going to explain in the next slides. Don't get scared about them. Just want to bring them here to us, and then we see how we can define them. So these are the different ways on how we can express the percentage concentration: the percentage weight in volume, percentage weight in weight, and percentage volume in volume. But now, how do you can define each? For example, percentage weight in volume. What does it mean? This is defined as the amount of drug in grams present in 100 mils of the drug product. This one is common in dosage forms like solutions, suspensions, and even there are some gases. So percentage weight in volume. This is defined as the amount of drug in grams present in 100 mils of a drug product, such as it depends in different dosage forms such as solutions, suspensions, and maybe gases. So this one we can remove it. For example, if I have 20% weight per volume, this means that I have 20 grams of the drug present in 100 mils of a drug product. I have an example here. For example, amoxicillin 120 milligrams per 5 mils. This is the solutions. So we're having amoxicillin suspension 125 milligrams per 5 mils, which means that 5 mils of suspension contains 125 milligrams of amoxicillin. Now you're going to see how this one intertwined or how this one links with the percentage at a later stage. Because I'm having a gram or a milligram in a volume. So the other one is percentage weight in weight. This is defined as the amount of drug in grams present in 100 grams of the drug product. And this is used in other dosage forms like semi-solid and solid, such as powders, dosage forms. Even you can have it in syrups, as we shall see at a later stage as we continue these presentations. For example, having a cycle of a cream BP 5% weight per weight. What does this mean? It means that I am having 5 milligrams of acyclovir is present in 100 grams of the cream product of the product. The last one in the percentage is percentage volume in volume. This is defined as the volume of a drug in milliliters present in 100 mils of a drug product. This is commonly in solutions, and we shall mostly find this one in ethanol, as we shall be continuing. For example, if I'm having 20% volume per volume of ethanol, it means that I'm having 20 mils of ethanol is present in 100 mils of a drug product. Now, this is a famous question on how they can ask us on they find the different ways on how express the strength of pharmaceutical products. So ensure at least you defined the percentage volume in volume. Even you give us the dosage form, percentage weight in volume, and percentage of weight in weight. These are the other questions which we can just briefly discuss. For example, having in the preparation of a pharmaceutical product, 10 grams of sucrose was dissolved in 40 ml of purified water. Calculate the percentage concentration. This is an easy thing. The quantity in gram, this is the formula, quantity in grams, divided by total volume times 100. So 10 grams divided by 40 mils times 100. So the answer would be 25% weight. So you can just express it like this: weight in volume. Another question is this one. A 5 milligram eye ointment contains 2% weight in weight of the tetracycline. How many milligrams of tetracycline will be used in the product? If you ever have such a question, it is good you first interpret this. What does this one mean? It means 2 grams in 100 grams. So just as simple as saying 2 out of 100 times 5, giving me 0.1 grams of tetracycline. However, remember the question wants us to write the answer in milligrams. So you have to convert the answer to milligrams. And using that conversion, you can easily come up with the answer in milligrams of tetracycline. The other ways on how we can express the strength of pharmaceutical product is using ratios. These ratios are used to indicate the relation of two quantities, while a proportion is an equation that states the two ratios are equal and written as fraction. So all of us remember ratios written with the word the two dots, these ones here. However, proportion is just an equation that states two ratios are equal and written as fractions of ratios. So we shall see these two as we progress. Uh, this statement is key. While converting to ratio strength, any weights should be in grams and any volume should be in milliliters. This statement is important. These are some questions. For example, they say, you're having the strength of dextrose, but convert it to ratio strength. Always first interpret this. We say this is weight in volume. Interpret it like this: 20 grams in 100 mils, and then introduce the two dots, remove the in and then the units, but reduce to the smallest units and always show the working. In ratios, we don't have points always. We don't have points. So avoid points. So convert, this is another question. Convert 1 out of 400 to decimal fraction or ratio strength and the percentage. This is just a decimal ratio. We said we just remove the division and then introduce the two dots. As a decimal fraction, just put it in the calculator. The answer you get is this. But converting a ratio to a percentage, just as saying 1 out of this times 100, just multiply by 100. Then we introduce the percentage sign. You don't introduce the percentage sign here, like this, like what most of you usually do, times 100%. No, we don't put it there. We don't put it there. The percentage sign goes on the equation. Now, the other way on how we can express strength is specific gravity. This one is going to be important when we shall be converting, especially volume to weights. And specific gravity is derived from density. Density is the weight or mass of any given substance that occurs in a given volume, or divided by the given volume. And this one is key in understanding specific gravity, because specific gravity is the ratio of the mass or weight of any given substance to the mass of equal volume of water. So if you're having specific gravity, as this is the equation, equals the weight of a substance over weight of equal volume of water. Or maybe weight of substance divided by, I think, we usually use the word volume, the equal volume of a substance, equal volume of a substance. I think this one would be better. Though in a definition, they usually use water because water is used as a universal solvent. Now, this specific gravity is basically important when you go to the lab when we shall be preparing the syrups, because they can give you the volume of a syrup. I want you to prepare that product, and syrups will be prepared in what? In weight. So they will give us a specific gravity and we shall convert that volume to weight by using this simple formula. So specific gravity just enables us to convert between weight and volume. And I will repeat this one, be important when you go to the laboratory, we shall be preparing syrups. The other way on how we can express concentration is parts per million and parts per billion. As the word sounds, parts per million, because now with the percentage it was in 100, but now here I shall have 6 zeros. Parts ppm is defined as, so this one can be written as pp in capital letters, ppm. Then this one can be written as parts per billion, ppb. So ppm is defined as the parts of a component per a million parts. That's as simple as that. This is mostly used to express the concentration of very dilute solutions or to indicate the presence of trace quantities of contaminants or elements in a given products. For example, if I'm having 5 ppm, it means that 5 to 1 million parts. So you can convert this one to a percentage by just giving us 5 out of 1 million times 100. Then the answer indicates the percent sign. ppm is defined as the parts of the component per billion parts of a solution. So per 9 zeros, like this. So we can interconvert between the strength to PB to either per million or per billion by using these equations. There are other ways on how we can express strength which will be discussed as we shall be progressing, like mid equivalents, mid osmoles, molarity, and normality. Number of molarity is number of moles per liter of a solution. Molarity number of moles per kilogram of a solvent. Normality, mid equivalent is also there, and mid osmoles as you have seen. This one is if you go on these ones are basically used on normal saline or sodium chloride product. You'll see the concentration written as mid osmoles or milli equivalent. This topic is key in understanding. The pharmaceutical products and in also identifying the pharmaceutical product, because in identification of pharmaceutical products, it is important you state the strength of the active drug. Don't just write the name and it doesn't